So let's start with 5.6. I think the graphs are really pretty hard for the moment. So we're moving out of the graphs into more other kinds of trigonometry. And here we have what most of you know as SOHCAHTOA. So I think most of you learned this in high school. Of course, if you didn't, that's okay. I didn't. This was, I think, after my... I think this is newer than when I learned trigonometry. So those of you who know this, that's fine. The sine, for me, this is the best way I know how to learn it. The sine is the y value, and the cosine is the x value. So as you can see, if this is the angle, then the opposite is the y, right? And the hypotenuse is the hypotenuse. And the adjacent is the x. And the hypotenuse is, again, the hypotenuse. So it doesn't change from the y value being the sine and the cosine being the x value. The only thing that changes is we can have triangles now where our hypotenuse is not 1. Because we learned the sine is the y and the cosine is the x, but that's because we've also had the hypotenuse equal to 1, right? So as long as the hypotenuse is equal to 1, that's true. The minute the hypotenuse is not equal to 1, oh, sorry. I was trying to erase it, but I guess I can't erase it. The minute the hypotenuse is not equal to 1, that goes out the window. Okay, so let me show you what I mean. Here we're given that the sine of theta equals 4/7. And we want to find the remaining trig functions. Well, notice the sine is still always less than 1. But what's the easiest way to do this? So we can make a triangle. And if this is my theta, right, then the sine is equal to the y over the hypotenuse. Does that make sense? Okay, good. So now, if that's true, how do I find, we'll call this x. How do I find x? Right, I just use Pythagorean. So I have x squared plus, it's squared, plus 4 squared is equal to 7 squared. Or I have x squared is equal to 49 minus 16, which is equal to 33. So x is equal to the square root of 33, right? Okay, so now, that's cool. I have all my values. And now I can say the cosine. So what is the cosine? So this is equal to the square root of 33. So what's my cosine of theta equal to? Yeah, exactly. Square root of 33 over 7. Right? And so on and so forth. Do you need me to go through all of them? I will if you want me to. Does anybody want me to go through all the trig functions? Okay. So then we know what the sine is. We know what the cosine. Then we need to know tangent. What's the tangent of theta? Yeah. 4 over the square root of 33. Exactly. Sorry. So hard to write. Not 7/4. So remember, the tangent is the sine over the cosine, or the y over the x, isn't it? Okay. So here, I'm gonna start all over. Here, hold on a second. So I have I'm gonna just delete everything. So we know that we have this triangle. Let me just rewrite it so I have some space. So we have a triangle. This is 4, 7, and the square root of 33. So we have the sine of theta we're given is 4/7. The cosine of theta is equal to the square root of 33 over 7. The tangent of theta is equal to 4 over the square root of 33. So Savant's question is I believe at this point you don't have to rationalize anymore. Has anybody done any of this homework? Do you have to rationalize? Are you sure? Or did you just do it? You do have to rationalize? Okay. Okay, so you still have to rationalize. There will be a point at which you don't have to rationalize anymore. It's coming very shortly. Okay, so we have those. And then we have, so the reciprocal of the sine is what? Exactly, the cosecant. So the cosecant of theta is equal to 7 over 4. That means the secant of theta. Okay, so here, rationalize this would be, 4 times the square root of 33 over 33. The secant would be 7 over the square root of 33, which is 7 times the square root of 33 over 33. And the cotangent of theta would be equal to the square root of 33 over 4. Okay, so that's basically it. Any questions? All right. Okay, so here, now this would be a non-calculator problem, right? If I want to know what, so here for this one, I have, this is 30 degrees, and I want to know what B and C is. So everybody try to put away your calculators. I mean, put them, don't use them. We might have some problems that we need calculators for. I'm not really sure in this section, but this is not a calculator problem, okay? So what would I do here? How would I find B and C? Let me see. Don't let anybody answer. I'm going to start calling on people. Arian, how would I find B? Good. So Arian says take the sine of 30 degrees. So the sine of 30 degrees, well, the sine is equal to the opposite over the hypotenuse, right? What's the sine of 30 degrees, Arian? Good. So we know that sine of 30 degrees is 1/2, so I have 1/2 is equal to 17.9 over C. And then I solve for C. C is equal to 2 times 17.9. Which is 35.8. Okay, thanks, Savant. Okay, so there's what C equals, and now I have C. How would I find B? Don't let anybody answer. I'm going to call on people. So, Caesar, how do I find B?
parabola theorem? God damn it.
That's one way. What's another way if we don't use that? That's not wrong, by the way. It's just a little harder to use that because I'm trying to do this without a calculator. And I definitely don't want to square 17.9 or 38.8 without a calculator. So what else could I do? So the clue would be using my trig functions. So Stacy, don't answer like that's one way, but that's not the way. Let's just use the angle I have. So let's wait. That's okay. Let's wait for Caesar. So how would I find it? Kind of the same, but different. Caesar, do you know? Okay, no problem. Delisha. Yeah, exactly. So if the sine is the opposite, the sine is equal to the opposite over the hypotenuse. The cosine is equal to the adjacent over the hypotenuse. So the adjacent, so I can say cosine of theta is equal to b over 35.8, right? So that means that b is equal to 35.8 cosine of theta, cosine of 30. What's the cosine of 30? I could also say the tangent, you're right. What's the cosine of 30 degrees? Good. So we have b is equal to 35.8 times the square root of 3 over 2. So that's 17.9. 0.9 times the square root of 3. So that would be our solution, right? Does anybody have any questions about this? Probably not the best way to go, Darla. We kind of, those were kind of just to get you used to things, but I would probably mostly leave those behind. Because the trigonometry is more the sines, cosines, tangents, you know, that way. Okay, no questions? Any questions? All right. So this would be a calculator problem that would be exactly the same, but because the angle here is 32, I would have to use a calculator to find my angle. Okay, it's nothing different. It's exactly the same as the last problem. So I'm not going to do this one. I'm going to go on.